Ms. Teasley here, section 2.7, inverse function. So previously we talked about operations of functions, and one of the operations we looked at was composition of functions. So composition, that f of g of x, that open circle, that's not multiplication, that's composition. So this is what inverses are. It says two functions, f and g are inverse functions if this composition stuff applies. All right, so if I do f of g of x, or if I do g of f of x and I get x back, that's how I verify and determine if they're inverses. So starting with the first example, I'm going to do f of g of x. It doesn't matter which one I do. I'm actually going to do both for this example. So to do f of g of x, you start off with f of x. All right, so let me go over here to the side. So I'm going to go over here, I'm trying to find f of g of x. So since I'm trying to find f of g of x, I start with the f of x function, which is 3x plus 4. And the next step is I take x out the picture. So replace all your x's, which is blank parentheses. And inside the parentheses, we're going to put g of x. Now, f of g of x written in that form is the same thing as f with g of x in parentheses. So inside your parentheses, you're going to put g of x. So that green stuff goes there. On the left side, you just write g of x. But on the right side, in the parentheses, you put down what g of x equals, which is this fraction. So x minus 4 over 3. And now you need to simplify this right side. If you notice, the 3 here and the 3 in the denominator, they cancel out. And so you're left with x minus 4. And then you still have that plus 4 at the end. X minus 4 plus 4 is x. So because my final answer is x, that lets me know that f and g of x are inverses of each other. I'm going to do it g of f of x. You don't have to do both ways, but I just want you to see that regardless of which order you go in, if you get x, they're inverses. All right, so it should be the same when I do it the opposite way. So now I'm going to start with g of x, which is this fraction. Let me erase what I'm... So what I'm trying to do is I'm trying to find g of f of x. Which is g with f of x in parentheses. So you start off with the g function. G of x is this fraction, x minus 4 over 3. You take x out the picture, leave it with blank parentheses. So everywhere you see an x, you're going to put blank parentheses. Inside the parentheses, you're going to put f of x. So over here, we have f of x in the parentheses. So everywhere there's a parentheses, we're going to put f of x. On the left side, I just put f of x. But on the right side, in this first parentheses, in this fraction and numerator, I'm going to put what f of x equals, which is this 3x plus 4. And then I simplify. So I get 3x plus 4 minus 4 all over 3. The 4's cancel out. So I'm left with 3x over 3. And then the 3's cancel out. So my final answer is x. So just like before, I get x. So that's how you verify that two functions are inverses of each other. You find the composition. The next example I want you to try. So you try example 2. All right, so hopefully you try example 2. To determine if they're inverses, you're going to find f of g of x or g of f of x. I'm just going to find the first one, f of g of x. Remember, that's the same thing as f with g of x in parentheses. So I'm going to start off with my f of x function. So that's x cubed plus 2. Take x out the picture. Everywhere there's an x, you put blank parentheses. And inside the parentheses, you put g of x. All right, g of x equals the cube root of x minus 2. So over here, this is the cube root of x minus 2. When you raise a cube root to the third power, they cancel each other out. All right, they're inverses of each other. So this 3 out here cancels out with that cube root, and you're left with x minus 2. You still have that plus 2 at the end. So x minus 2 plus 2 is x. So therefore, because I get x as my final answer, this lets me know that f and g of x are inverses of each other. Why does that happen? What does this mean? So if you notice, we didn't do the part where it says graph both f and g. So I'm going to go back to the previous example, and I'm going to, in Desmos, graph both functions. All right. So the first one is 3x plus 4. All right, so this one is f of x. And you don't have to put f, but you could just put y equals. All right, but y equals x plus, hold on. It's 3x plus 4. So 3x plus 4. So that's the graph of the first one. And then to get the graph of the second one, I need to do y equals. Since you have a fraction, you hit the division button first. And it was x minus 4 over 3. So there you have the red graph, which is f of x, and then you have its inverse, which is g of x. The reason why the composition is x is because when you graph an inverse, when you graph inverses of each other, they're symmetric to the line y equals x. So let me show you what y equals x is. Y equals x is just a line that goes through the origin with a positive slope. So y equals x. So basically, if I had paper, this is on paper, if I fold my paper diagonally along this green line, the blue and the red would match up. All right, they're symmetric to the line y equals x. So that's where that x comes from. So when you do composition, you get x. Same thing if you graph, they should be symmetric to the line y equals x. Let's look at the other example on a graph. X cubed plus 2. So I'm going to change this to x to the third power plus 2. And then this was the cube root. All right, the cube root button should be, I don't see it down here, so I'm going to hit functions and go over to miscellaneous. And then you hit the button that has this n and a square root beside it, so it looks like this. So this should be the cube root, and then it's x minus 2. So I have both functions, they're inverses of each other. If you were to fold your paper along that green line, then the blue and the red would match up. They would meet. It's symmetric. Okay, so that's functions. So it says recall the definition of a function. Definition of a function is that a function is a relation where x values do not repeat. It passes the vertical line test. Right. So now we have what we call a one-to-one function. All right. So a one-to-one function, a function f is called one-to-one if each element in the range, all right, so range is the y value, corresponds to exactly one element in the domain. So that's x. If a function is one-to-one, then it has an inverse function. All right. So basically, a one-to-one function, all right, so to put it in simple terms, a one-to-one function is a function where the inverse is also a function. So it's a function to start off with. And then if I find the inverse is also a function. So that means it will pass the vertical line test. Well, instead of you having to find the actual inverse to figure out if a function is one-to-one, we use what we call the horizontal line test. Horizontal line test works just like a vertical line test. You shouldn't be able to hit more than one point if you put a horizontal line on your graph. So first of all, it says which of the following functions are one-to-one. All right, so you want to know which one of these are one-to-one. So basically, all of these are functions. If you remember from our previous section, I kind of briefly went over all these functions. You have a quadratic, a cubic, a square root, a cube root, and an absolute value graph here. These are all the parent functions. And they want to know which one of these are one-to-one functions. They're all functions, but which one are one-to-one? Well, the first one, which is the quadratic y equals x squared, this is not one-to-one. Because if I put a horizontal line, it's going to hit more than one point on that graph. What's special about those 2 points? They have the same y value. All right, so that's basically what it said in that box. So basically, since I can hit more than 1 point with this horizontal line, this is not one-to-one. So not one-to-one. All right, the next one, let me use a different color. Here, if I put a horizontal line anywhere on this graph, it's only going to hit 1 point at a time. Even in the middle, it's not constant, it's constantly decreasing. So this is actually decreasing. So this is a one-to-one function. All right, so these points actually increase here in the middle. So this is not a horizontal line, it's constantly increasing. So anytime I put a horizontal line, it's going to hit 1 point at a time. So this is a one-to-one function. This is a cubic curve, y equals x to the third. So a cubic is one-to-one. Then you have this square root, y equals square root of x. This is a square root curve. This is also one-to-one. Because if I put a horizontal line on this graph, it's only going to hit 1 point at a time. So 1 point at a time. So this is one-to-one. All right, hopefully you understand what one-to-one is. All right, it works just like the vertical line test, except you're looking at a horizontal line. Sometimes I'll say a quick way of doing it also is just to turn your paper horizontally and use the vertical line test. It's the exact same thing. All right, here, this is a cube root function, y equals cube root of x. This is a one-to-one. And then your last one is y equals the absolute value of x. This is not one-to-one. Because if you put a horizontal line, it's going to hit more than 1 point over here. These 2 points will have the same y value, so this is not one-to-one. This is not a one-to-one function. So out of all the parent functions that I have listed here, the only two that are not one-to-one is the y equals x squared, and then the y equals the absolute value of x. Now we're going to talk about actually how to find the inverse of a function. Now they have functions, the actual equations. Let's look at a simple way of finding, looking at one-to-one functions using ordered pairs. So let's say, for example, if I have a function f of x equals -1, 3, -2, 4, and then 3, 4. First of all, this is a function because none of the x values repeat. So we have a function. To find the inverse, you switch x and y. So you literally switch the position between x and y. The notation for inverse, since the original function is f of x, The inverse is f with the negative 1 of x. So that's the notation. You don't have to worry about typing that in. My math lab, they actually give you that, but that's what that means. That means the inverse. So to find the inverse of a function, you just switch x and y. So when you go to the first order pair, it's negative 1, 3. So that's going to be 3 comma negative 1. You just switch the positions. You don't change any signs. You just literally switch the position of x and y. The next order pair would be 4, negative 2. And then the last one would be 4, 3. So this is the inverse of that function. The question is this function a one-to-one function? If it is a one-to-one function, that means that the inverse of it should also be a function. So when you look here, how do you determine if something is a function? You look at the x values. So if you notice here, the 4's repeat. So since the 4's repeat, that means the inverse, f of x, is not a function. So therefore, the original function, f of x, is not a one-to-one function. All right, so that's what it means about one-to-one. I use this example also to show you the steps on how to find an inverse. So they gave us some examples here. They gave us some functions, and they want us to find the inverse of it. So to find the inverse, you just switch x and y. So I'm going to go through the steps. So when they give you the function, the first thing you want to do is you want to write it without that f of x. So first thing you want to do is you want to rewrite using y. So this would be y equals 1 over 2x minus 3. So I rewrote the original problem using y equals instead of f of x. Then you switch x and y. So wherever I see the letter x, I'm going to put y. And wherever I see y, I'm going to put the letter x. So this is, this is y. Sorry, this is x now, because I'm switching 1/2 and then y minus 3. So I switched to position of x and y, just like you did with the order pairs. And then the next step is to come back and solve for y. So you have to take this equation and you have to come back and solve it for y. So what I need to do first is add 3 to both sides. So this is x plus 3 equals 1 over 2y. To get y by itself, I'm going to multiply both sides by 2. So I'm going to put a parentheses because I need to multiply everything over here by 2. And that's your answer. All right, you can distribute this. This is 2x plus 6 equals y. This is the inverse. The notation will be f of negative 1 of x. So again, in my math lab, that's exactly what you would see. This is the inverse. And what you would type in the box is 2x plus 6. So that would be the inverse. So the inverse of that function. All right, the next example I want you to try. All right, so pause the video and try to do example 5. So you try. All right, so coming back here, first step is to rewrite the equation using y equals instead of f of x. So this is y equals x squared minus 3. Then I'm going to switch x and y. So x equals y squared minus 3. The next step is to come back and solve for y. So to solve for y, I need to get rid of this minus 3. So I'm going to add 3 to both sides. So this is x plus 3 equals y squared. To get rid of a y squared, to undo a y squared, you need to take the square root. So I'm going to put the square root of both sides. And normally when you take the square root of both sides, you need to put a plus or minus. I kind of took off this restriction, but in this case, they have x's greater than or equal to 0. We're only going to take the positive square root. So your final answer when the square and the square root cancels out is that the square root of x plus 3 equals y. So this is your inverse. So that would be your answer. And the way that you would see it in my math lab would be f of negative 1x equals the square root of x plus 3. This is what you will put into my math lab in this box. All right. All right, notice I took off the part where it says state the domain of range, because you don't have to do the domain of range, and you always can graph it and look at the graph to determine the domain of range. All right, so I'm going to try this example, and I'm going to let you do the next one. Determine the inverse of the one-to-one function. So again, the steps are the same. Rewrite the problem using y equals. So y equals the square root of x minus 4. Switch x and y. So this is x equals the square root of y minus 4. And then your next step is to come back and solve for y. So in order for you to get y by itself, y is underneath the square root. So I have to get rid of that square root first. So to do that, I'm going to square both sides. So when I square a square root, they cancel out, and I'm left with x squared equals y minus 4. To get the y by itself, I need to add 4 to both sides. So this leaves me with x squared plus 4 equals y. This is your inverse. Once you get y by itself, you're left with the inverse. Again, the notation for inverse will be f to the negative 1 of x. And the answer is x squared plus 4. Number 7, or example 7, will be an example that I want you to pause and stop and try on your own. So this is perfect time to stop and try this example, which is similar to the last one. All right, so let's see how you did. I'm going to rewrite this equation using y equals. So y equals the cube root of x plus 2. Switch x and y. So x equals the cube root of y plus 2. The next step is to get y by itself. So I have to get rid of the cube root that's over it. So to get rid of this cube root, I'm going to raise both sides to the third power. So that's how you undo a cube root. And what you do to one side of the equation, you got to do to the other. So the cube root and cube cancels out. So this is x to the third equals y plus 2. To get y by itself, I'm going to subtract 2 from both sides. So this is x cubed minus 2 equals y. And that is your inverse. Your inverse is x cubed minus 2. So the way that you should write it is f to the negative 1 of x equals x cubed minus 2. This is your inverse.